So, what would any algebra class be without the quadratic formula? So, we're going to talk about the general form of a parabola. We've seen the standard form and the quadratic formula. So, the standard form is this. H and K are your coordinates of your vertex. A is the stretching factor. Ax squared plus bx plus c. That's another way to write a parabola. So, how do you go from one to the other? If you have the standard form like that, it's easy to get the general form, the x squared plus bx plus c form, just by multiplying it out. So here y equals 3, x minus 2 squared minus 4. 3 is times this whole thing. So we'll put that in a little bracket and do a side calculation. What's x minus 2 quantity squared? Remember that squaring something is multiplying it by itself. So we get this, x minus 2 times x minus 2. We have to FOIL that out. X squared minus 2x plus 4. First, outer, inner, last. And that's x squared minus 4x plus 4. So that's this thing multiplied out, and I need to put it inside of these brackets. This whole thing gets multiplied by the 3. So it's 3 times x squared minus 4x plus 4. And then a minus 4 at the bottom. We multiply that out. We get 3x squared minus 12x plus 12 minus 4. That's just distributing the 3 to each one of those. And that's 3x squared minus 12x plus 8. So there's our conversion from standard form to general form. You just multiply it out. Going from general form to standard form is a little bit more complicated. It involves the following procedure, which I will explain in due course. So I have this, and I want to have this. To do that, I have to find the stretching factor A, and I need to find out where the vertex is, hk. So basically the problem becomes, if I've got this equation, how do I find the stretching factor and how do I find the vertex? And the stretching factor is just the same, it's just A. H, I'm not sure why this was there. H is minus b over 2a, that's the x-coordinate of the vertex. We'll explain a little bit where that came from. And to find k, well, k is the y-coordinate of the vertex. So to find the y-coordinate, you take the x-coordinate, which is h, and you plug it into your formula, y equals x squared plus bx plus c, and then you get k. So here's a parabola. We want to turn, it's in general form, x squared plus bx plus c form, and we want to turn it into standard form. We want to know what its vertex is, what's its x-intercepts, what's the graph look like, all that kind of stuff. So we want to convert it to y equals a x minus h quantity squared plus k. A is the same in both. So a is 2. So we know that. H is given by the formula minus b over 2a. In this case, b is 6. So it's minus 6 over 2 times 2, which is 4. So minus 3/2. We'll simplify that a little bit. And then what is k? K is what you get when you plug h, which is this number, in for x into that. So it's going to be 2 times minus 3/2 squared plus 6 times minus 3/2 plus 12. Okay, remember your order of operations. We have to do the squaring first and then the multiplication. So k equals 2 times 9/4, because it's minus 3 over 2. 6 over 2 is minus 18 over 2. 6 times minus 3 over 2 is minus 18 over 2 plus 12. I want to keep all the 2's because I'm going to find a common denominator. This can cancel one of those. And so I have k equals 9/2 minus 18/2 plus 24 over 2. That's my 12. 24 over 2, so everything's over a common denominator. So k is 9 minus 18 is minus 9. Minus 9 plus 24 is minus 15. Plus 15 over 2. So a is 2. X minus 3/2, so that's x plus 3/2 squared. Plus 15 over 2, because that's k. So there's my equation. Vertex, minus 3 over 2. Comma 15 over 2. X-intercepts, well, I haven't graphed it yet, but what do I know about the x-intercepts? I've got a vertex that's above the x-axis, and it opens up, so there are none. Right? If you graph it, it'll look something like that, so there'll be no x-intercepts. Okay, so we can take something in this form, we can convert it to standard form. Most importantly, we can find the vertex. H is minus b over 2a. You get k by plugging h back into your formula. So how do we find the x-intercepts directly from the equation y equals 2x squared plus 6x plus 12? That's the quadratic equation. If ax squared plus bx plus c equals 0, then x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So here, what are the x-intercepts here? A equals 2, b equals 6, c equals 12. So x equals negative b, negative 6, plus or minus the square root of b squared, which is 36, minus 4ac. And 4ac at this point is 4 times 2 times 12, which is 8 times 12, which is 96. All over 2a, and 2a is 4. So x equals minus 6 over 4, plus or minus square root 36 minus 96 is minus 60 over 4. And we can simplify this a little bit. Right? Minus 6 over 4 is minus 3 over 2. And we'll note square root of minus 60. We can rewrite that. The minus sign is an I squared. 60 is 4 times 15. So here's a square, here's a square. So we get an I and a 2, but the 15 stays inside. So it's minus 3 halves plus or minus I 2 root 15 over 4. And then we can cancel out this 2 and one of the 2's. So we get x is minus 3 halves plus or minus I square root of 15 over 2. So there's our two roots. They're not x-intercepts because they have an I in it. And we know they're not x-intercepts because this graph has no x-intercepts. So we have two roots, right? That's that, but 0 x-intercepts. So if you solve the quadratic equation and you get complex numbers, that means your graph doesn't have any x-intercepts. It doesn't go through the x-axis. So here's the derivation of the quadratic equation, which you're not expected to remember, but it's a good thing to see once in your life. So take this equation, set y equal to 0, and then complete the square. So 0 equals x squared plus bx plus c. Subtract a c from both sides, gets this equation. Divide both sides by a, so we just have an x squared there, and we have this equation. So how do we complete the square root at this point? We take 1/2 of the x term, which is b over 2a, and we square it, and we add that to both sides. So I get b over 2a squared minus c over a equals x squared plus ba over x plus b over 2a squared. And so then this side, what that does is it completes the square. This is now a perfect square, x plus b over 2a quantity squared. This side, if we simplify it a little bit, this is b squared over 4a squared minus c over a, because if I square that, and I need to get a common denominator of 4a squared, so I'm going to multiply top and bottom by 4a. So that gives me a 4a squared as my common denominator, b squared minus 4ac as the numerator. And of course, that's the famous b squared minus 4ac inside the square root. So how do I get rid of the square root? How do I get rid of the square? I take the square root of both sides. So I get a plus or minus. Square root of this whole thing is x over b plus 2a. Subtract the minus b over 2a to either side. We have this square root. And you can simplify it a little bit. Square root of the top divided by square root of the bottom, but the square root of the bottom is 2a. Common denominator, so you bring them together. This is a useful thing, though. Minus b over 2a equals x coordinate of vertex. And then this thing is telling me sort of the width. How wide is that graph at the point, right? So this is where the vertex is. This is how far left and right of you go of the vertex to get to your x-intercepts. So here's an equation. Find the x-intercepts using the quadratic equation. Ooh, there we go. interpret the two parts of the quadratic equation, find the vertex, and rewrite the equation in standard form. So x-intercepts are set y equal to 0. And remember, whenever you're using the quadratic equation, you have to start with 0 on one side. So here a is 1, b is minus 2, c is minus 10. Quadratic equation, x equals negative b plus or minus square root b squared minus 4ac all over 2a. And that's one of the reasons why I ask you to write these things out. Make sure you write that so you can remember it. So b is minus 2, minus 2 is plus 2, plus or minus the square root. B squared is 4, minus 4ac, a is 1, 4 times 10 is 40, so minus 10, so this becomes a plus 40 all over 2a, which is just 2. So x equals 2 plus or minus the square root of 44 all over 2. 44 is 4 times 11. So we can rewrite this as 2 plus or minus 2 times the square root of 11. And so that can be simplified. Factor a 2 out of the top. And once it's factored, you can only cancel out of things that are factored. So I can cancel those 2 now, and I get 1 plus or minus the square root of 11. So what does that tell me about my graph? Well, if I graph my parabola, I have 1 here. And if I go square root of 11 to the right, I get 1 x-intercept. And if I go square root of 11 to the left, I get the other x-intercept. A is positive, so we know it's opening up. So the graph looks like that. We know that the vertex is at 1 comma something. How do I get, if I know the x-coordinate, how do I get the y-coordinate? I just plug it back into the original function because the x-coordinate of the vertex is 1. So k is 1 squared minus 2 times 1 minus 10, which is 1 minus 2 minus 10, 1 minus 12, k equals minus 11. So there's my equation. So if I know where the two, so if I look at the results of the quadratic equation, the thing before the plus or minus, that's where your vertex is. This is how far left or right you go to get to the x-intercepts. So what's the standard form of this? A is the same, that's 1. X minus the x-coordinate of the vertex, which is 1 squared minus k. So that's another way to write it. X minus 1 squared minus 11. It's the same thing as that. Okay.